So 0.01 into 0.01 is 0.0001. 3 zeros and 1. Now therefore 45 minus 5r is equal to 0. 45 is equal to 5r. R is equal to 45 divided by 5, that's equal to 9. R is equal to 9. The value of root 3 plus 1 to the power of 5 minus root 3 minus 1 to the power of 5 is equal to 152. Okay. Hello dear students, welcome to this session of Basic Mathematics Revision class. I am Mr. Niranjan, Faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session, I am going to discuss very easiest and simple chapter, that is Binomial Theorem. So in this chapter, you are going to get one question either for 4 marks or 5 marks. So one 4 marks question which is from application of Binomial Theorem, and one 5 marks question. Right. So one question for 4 marks, that is in part E, that is for 4 marks from application of Binomial Theorem. Another one is 5 marks question. So you may get one question either for 4 marks or 5 marks from this chapter. So now let us discuss the 4 marker first, the application of Binomial Theorem. So just listen, just recall the statement: if n is any integer, n is a positive integer, and then the expansion of x plus a to the power of n is equal to x raised to n plus nc1 x to the power of n minus 1 into a plus nc2 x to the power of n minus 2 into a square, etc., etc. The last term a to the power of n minus 1 is called the binomial theorem. Right. So x plus a to the power of n is x raised to n plus nc1 x to the power of n minus 1 into a plus nc2 x to the power of n minus 2 a square, etc., a to the power of n minus 1. So there are n plus 1 term in the expansion. So the number of terms in the expansion of x plus a to the power of n is n plus 1 terms. So the general term or nth term is denoted as Tn is equal to ncr x to the power of n minus r into a to the power of r is the nth term or general term in the expansion of the binomial theorem. So if you know these two formulas, so you can easily solve the problems. Now move on to the first problem. Let us discuss one 4 marker question, that is from application of a binomial theorem. Find the value of 1.01 to the power of 5 using binomial theorem up to 4 decimal places. Right. Now expand 1.01 to the power of 5 using binomial theorem up to 4 decimal places. So the given equation can be written as 1.01 to the power of 5 can be written as 1 plus 0.01 to the power of 5. Now if you observe carefully here, x is equal to 1 and a is equal to 0.01 and n is equal to 5. Right. So therefore 1.01 to the power of 5, that is nothing but 1 plus 0.01 to the power of 5. So using the formula x raised to n, what is x here? 1 to the power of n plus nc1, that is 5c1 x to the power of 1 to the power of 5 minus 1 into a is 0.01. Next, after 5c1 it is plus 5c2 1 to the power of 5 minus 2 into 0.01 whole square, plus after 5c2 it is 5c3 1 to the power of 5 minus 3 into 0.01 whole cube. Next, after 5c3 it is 5c4 1 to the power of 5 minus 4 into 1.01 whole raised to 4, and the last term is 5c5 1 to the power of 5 minus 5 into 1.01 to the power of 5. So just substitute in the formula. Right. X plus a to the power of n is x raised to n plus nc1 x to the power of n minus 2 into a square, etc. The last term ncn nc5 1 to the power of 5 minus 5 into 1.01 to the power of 5. Now this can be written as, let me write, this is, now just we know the formulas, write down the formulas for 5c1, 5c1 is equal to 5 and 5c2 is equal to 10 and 5c3 is also equal to 10, and what is 5c4? 5c4 is equal to 5 factorial divided by 5 minus 4 is 1 factorial into r is 4 factorial, 4 and 4 gets cancelled, you will get 5, and 5c5 is equal to 1. Right. Now, so this can be written as 1 to the power of 5 is 1 plus 5c1. What is 5c1? 5c1 is equal to 5 into 1 to the power of 4 is 1 into 0.01 whole square, 0 into 0.01, 0.01 plus after 5c1 it is 5c2, 5c2 is 10 into 1 cube is 1 into 0.02 whole square. So 0.01 into 0.01 is 0.0001, 3 zeros and 1 plus next term. So that is 5c2 for 5c2, 5c3. What is 5c3? 5c3 is equal to 10 into 1 square is 1 into 0.01 whole cube. That is nothing but 0.01 into 0.01 into 0.01. Just multiply 0.001 into 0.01. So point followed by 5 zeros. 0.000001 and plus neglecting all the terms. Now just multiply this. So 1 plus 5 into 1 is 5 into 1 is 5 into 0.01 plus 10 into 1 is 10 into 0.0001 plus 10 into 1 is 10 into 0.00001, neglecting the next term. So this is equal to 1 plus, so 5 into 0.01. So 5 into 0.01 is 0.05 plus 10 into 0.001 is equal to 0.0001, right? Again 10 into 0.00001, that is 501 is equal to 0.0001, 4 zeros you will get. Now simplify this. So if you add this, what you will get? 1 plus 0.05 plus 0.001 plus 0.0001 is equal to, so this is equal to 1.0510 up to 4 decimal places. So the required answer is therefore 1.01 to the power of 5 up to 4 decimal places is 1.0510. That's it. So if you solve this much, you will get 4 marks. Now move on to the next problem. These are all 5 marker questions. These are all for 5 markers. Find the coefficient of x raised to 5 in the expansion of x plus 1 over x square whole to the power of 17. So what is to find the coefficient of x raised to 5? Now just comparing with x is equal to x, a is equal to 1 over x square and n is equal to 17. Now using the nth term, we know tr plus 1 is equal to ncr x raised to n minus r into a to the power of r. So tr plus 1 is equal to n. 17c, r we don't know. X, what is x? X itself. N is equal to 17 minus r into a. What is a? A is 1 over x square whole raised to r. So this is 17cr, x to the power of 17 minus r. Take this to the numerator, it becomes x raised to minus 2 whole raised to r. So tr plus 1 is equal to 17cr, x to the power of 17 minus r minus 2r. This can also be written as tr plus 1 is equal to 17cr x to the power of 17 minus 3r. Let us represent this as equation number 1. That is tr plus 1 is equal to 17cr x to the power of 17 minus 3r. Now for coefficient of, what is to find coefficient of x raised to 5? For coefficient of x raised to 5, equate this. X to the power of 17 minus 3r is equal to x to the power of 5. So bases gets cancelled. 17 minus 3r is equal to 5, or 17 minus 5 is equal to 3r. What is 17 minus 5? 17 minus 5 is equal to 12. 12 is equal to 3r. Therefore r is equal to 12 by 3, that's equal to 4. R is equal to 4. Now put r is equal to 4. Now put r is equal to 4 in equation number 1. So you will get 4 plus 1. T5 is equal to 17c4 x to the power of 17 minus 3 into 4. So this is 17c4 x to the power of 17 minus 12. 17c4 x to the power of 17 minus 12. What is 17 minus 12? That's equal to 5, x raised to 5. So what is to find? Coefficient of x. So therefore coefficient of x raised to 5 is 17C4. Simplify, you'll get the answer. That's it. So therefore the required answer is 17C4. If you want, you can simplify, or if you want, you can also write 17 factorial divided by 4 factorial into 17 minus 4. 17 minus 4 factorial. Simplify, you will get the answer. So you can stop there itself. Now move on to the next problem. Find the term independent of x in the expansion of this. So x cube minus 3 by x square whole raised to 15. Same as that of the previous problem. For independent or constant term, equate the power of x to 0. That's it. Now comparing with the standard equation, x is equal to x cube and a is equal to minus 3 by x square, n is equal to 15. Just find out r first. Now what is the general formula? TR plus 1 is equal to NCR x raised to n minus r e to the power of r. So TR plus 1 is equal to n. What is n? N is 15. N is 15. CR x. What is x? X is x cube whole to the power of 15 minus r into a minus 3 by x square whole to the power of r. So this is 15 CR x to the power of 15 into 3 is 45 minus 3r. Just take this x square to the numerator, it becomes x to the power of minus 2 whole raised to r is x raised to minus 2r. So this is 15 CR x to the power of 45 minus 3r minus 2r into minus 3 whole raised to r. So therefore TR plus 1 is equal to 15 CR minus 3 to the power of r into x to the power of 45 minus 5r. Let us represent this as equation number 1. Right. Now that is TR plus 1 is equal to 15 CR minus 3 to the power of r into x to the power of 45 minus 5r. Now for term independent of x, for independent term independent of x, for independent of x, equate this x to the power of 45 minus 5r to x power 0. Now therefore 45 minus 5r is equal to 0. 45 is equal to 5r. R is equal to 45 divided by 5, that's equal to 9. R is equal to 9. Now put R is equal to 9 in equation number 1. Put R is equal to 9 in 1. So you will get T R, that is 9 plus 1 is equal to 15C9 into minus 3 to the power of 9 into x to the power of 45 minus 5 into 9. So this is equal to T10 is equal to 15C9 minus 3 to the power of 9 into x to the power of 45 minus 9 5s of 45. Now T10 is equal to 15C9 minus 3 to the power of 9, x to the power of 45 minus 45 is 0. What is x power 0? 1. So T10 is equal to 15C9 minus 3 to the power of 9 into 1. So therefore the constant term, constant or independent term in the expansion is equal to 15C9 minus 3 to the power of 9. That's it. 15C9 into minus 3 to the power of 9 is the constant term or independent term in the expansion of the given problem. Right. The answer is 15C9 minus 3 to the power of 9. Now move on to the next problem. So evaluate root 3 plus 1 to the power of 5 minus root 3 minus 1 to the power of 5 using binomial theorem. This is also one of the application of binomial theorem. So first find out x plus a to the power of 5. Now just find out x plus a to the power of n. So here what is n? N is equal to 5. So simplify x plus a to the power of 5. So this is x raised to 5 plus 5c1 x to the power of 5 minus 1 is 4 into a plus 5c2 x to the power of 5 minus 2 is 3 into a square. Next term is 5c3 x to the power of 2 into a cube. Next 5c4 x to the power of 1 into a to the power of 4 plus 5c5 x power 0 into a to the power of 5. So therefore, this can be written as x plus a to the power of 5 is x raised to 5 plus 5c1, 5c1 is 5 x power 4 into a plus 5c2 is 10 x cube a to the power of 2, 5c3 is also 10 x square a cube, 5c4 is 5 x a to the power of 4, 5c5 is 1 into x raised to 0 is 1 into a raised to 5 is a raised to 5. Okay, right. Now, just similarly, I'll write again. Similarly, x minus a to the power of 5 can be written as, just replace a by minus a. What you will get? X raised to 5 minus 5x to the power of 4 into a plus minus again plus 10x cube a square minus 10 x square a cube again minus plus minus plus minus plus, this is plus 5x a to the power of 4 minus a raised to 5. Now subtract these two. Now therefore x plus a to the power of 5 minus x minus a to the power of 5. If you subtract this, what happens? So while subtraction, this becomes minus plus minus plus minus and plus. So my x raised to 5 and x raised to 5 gets cancelled. So plus 5 is 10. 10 times x to the power of 4 into a, one term we will get. Next minus 10x cube a square plus 10x cube a square gets cancelled. What we have? Plus 10x square a cube plus 10x square a cube is 20 times x square a cube and the next term is minus 5x a raised to 4 plus 5 a raised to 4 gets cancelled. What we have? Plus a raised to 5 plus a raised to 5 is plus 2 times a to the power of 5, a raised to 5. Now substitute the value. Put x is equal to root 3 and a is equal to 1. So we will get, therefore x is root 3 plus 1 to the power of 5 minus root 3 minus 1 to the power of 5 is equal to, substitute here, 10 into what is x? Root 3 whole raised to 4 into a is 1 plus 20 into x square root 3 whole square into a cube is 1 plus 2 into a is 1 to the power of 5. Simplify this, 10 into, so this can be written as 3 to the power of 4 by 2 into 1 plus 20 into 3 square root gets cancelled, 3 plus 2. So this is 10 into, so 3 square is equal to 9 plus 2 into 3 is 60 plus 2. So what is this equal to? 10 into 9 is 90 plus 60 plus 2. That's it. So if we simplify this, this is equal to 152. Let me check. The correct answer is 152. That's it. So if we simplify, I'll get the value of root 3 plus 1 to the power of 5 minus root 3 minus 1 to the power of 5 is equal to 152. Okay, that's it. Now move on to the next problem. Find the middle term in the expansion of 2x square by 3 minus 3 by 2x to the power of 10. This is also important for 5 marks. So just here, what is n? N is equal to 10, x is equal to 2x square by 3 and a is equal to minus 3 divided by 2x. So n is equal to, so here the number of terms, the middle term in this expansion is, for middle term, n by 2 plus 1th term. So what is n by 2? That is 10 by 2 plus 1. That is nothing but the 6th term is the middle term here, right? So n by 2 plus 1th term. So the middle term is the 6th term. Find out T6, that's all. T6 is the question mark. Now what is the formula? TR plus 1 is equal to NCR x to the power of n minus r a raised to r. T, for 6th term it is r is equal to, put r is equal to 5, that's it. So T5 plus 1 is, What is n? N is 10c5. X is 2x square whole to the divided by 3 whole raised to n minus r, that is 10 minus r is 5 into a. What is a? Minus 3 divided by 2x to the power of r is equal to 5. So T6 is equal to 10c5 2x square by 3 whole to the power of 10 minus 5 is 5 minus 3 by 2x to the power of 5. Simplify this. So T6 is equal to 10c5 2 to the power of 5, x to the power of 2 into 5 is 10, x power 10 divided by 3 to the power of 5 into minus 3 to the power of 5 divided by 2 to the power of 5 into x to the power of 5. So 10c5. So 1, 2, 5, 2 to the power of 5 gets cancelled. So what we have, x to the power of 10 minus 5 is 5, and this can be written as minus 1 to the power of 5 into 3 to the power of 5 divided by 3 to the power of 5 gets cancelled. 10c5. So x to the power of 5, if you multiply minus 1 5 times, you will get 5. So minus 10c5 x to the power of 5 is the middle term. Okay. So therefore T6 is equal to minus 10c5 x to the power of 5 is the middle term. That's it. Okay. So this is how we are going to solve this problem. Hope you follow. So these are few problems for 4 marks and 5 marks in your binomial theorem. So that's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.